Section 10.2, pressure. Pressure is defined as a force per unit area, or force divided by area. A force is equal to ma, or mass, times an acceleration. An area, of course, is like a length times a width, or a unit squared. So if we define this further, pressure is equal to mass times acceleration divided by a length times a width. And if we put units in for that, mass measured in kilograms, acceleration is equal to meters per second squared, or meters per second, and then we divide that by length times width, which would be meters squared. Well, this top set of units right here, kilogram times meter per second squared, has a new name. Well, it has a different name that maybe you've heard of. It is called a Newton, after Isaac Newton. And a Newton divided by a meter squared, actually has a new name as well. It is called a Pascal. And a Pascal is the standard international or metric unit of pressure. And so pressure is the acceleration of whatever the gas is times its mass divided by the area that it fills. If we look at the bottom of this page in Barometer Burstin, it's the digital page, page 440, you can see a figure right here where a cross-section of air, 1 meter by 1 meter, so that would be our length times our width, has a gravitational force, gravitational acceleration times the mass of the cross-sectional area multiplied together right up here, and then that pushes down on the Earth's surface. That is what's called atmospheric pressure. And so when we say we live in an ocean, we live in an ocean of air, it's this air right here that is on top of all of us and pushing down on us in every direction. So not just straight down, but also to the sides and also back upwards as well. So we live in a pressurized ocean with air pushing down on us in all different directions. We usually don't just use the Pascal, we usually use the kilopascal, Kpa, which is 1,000 times bigger than a Pascal because it's easier rather than putting like 10 to the 4th or 10 to the 5th. And the pressure on an atmosphere on Earth, this cross-sectional area right here, is around 100 kilopascals. Now, the actual atmospheric pressure depends on the weather and the altitude you're at, and as a matter of fact, that's how airplanes measure how high above the ground they are, is they'll measure their altitude and they'll check the atmospheric pressure, and that change in atmospheric pressure allows them to calculate how high they are in the air. So there are lots of other units of pressure that we'll see during this chapter. One is called the bar. 1 bar is 100 kilopascals. We'll see something called the pounds per square inch, or PSI. We'll see torr. Torr is used the same as what's called millimeters of mercury. They're equal to one another. And then we'll also see atmospheres, and we might even see some other ones as well. The weather stations usually use inches of mercury here in the United States, and so they just convert from millimeters to inches. So in the 17th century, many scientists and philosophers believed that the atmosphere had no weight. Along came a scientist that created this thing called a barometer. And a barometer was a tank filled with mercury. Mercury is a liquid, of course, at room temperature. And then they took a tube of the mercury and they tipped it upside down. Some of the mercury went down into the tank right here, but some of it still remained inverted in this tube. This height from the tank of mercury until the very tip top of the mercury was measured and used in either millimeters, inches, centimeters, and that was the pressure that was exerted on the atmosphere, on the surface of the mercury. So let's see if you can draw your own little picture of it. This pressure measuring device is known as a barometer. It has a tank of mercury, an inverted tube right here filled with mercury. Some of the mercury leaks out and goes back into this tube. but a lot of it is held up inside of the tube because there's an atmospheric gas pushing down on this mercury, and therefore it pushes back up against this mercury in the tube, and it holds the mercury up in the tube. This distance from the level of mercury here to how high it is in the tube is a pressure measurement. At sea level, here on Earth, that distance from here to the top is 760 millimeters. This is called standard atmospheric pressure. Standard atmospheric pressure is what the pressure of the air around us pushing down on us would be at sea level. Of course, where we are, we're 1,000 or so feet above sea level, and so our atmospheric pressure would be just a little bit lower. If you go to someplace in Colorado, like the top of a 10,000-foot mountain, your atmospheric pressure will be lower yet, because as we saw in this picture, as you move further and further away from the Earth and up this column, you'll have less of that air pushing down on top of you. That's why it becomes more and more difficult to breathe as you go to the top of a high mountain, or people on top of Mount Everest have very less air pushing down on top of them, and so they use supplemental oxygen so that they can breathe better. Here are some standard atmospheric pressures in various units. 760 millimeters of mercury, known as standard atmospheric pressure, is the same as 760 torr. It is also known as 1 atmosphere, symbolized ATM. It is also the same as 101.3 kilopascals, the kilopascal that we met over here, Kpa, the Pascal with times 1,000, kilopascal, which is equal to 14.7 pounds per square inch, or Psi. That's one that we see a lot when we fill up our tires. It's also equal to 1.013 bar. You have to become good at converting between these units because we'll interchange them many times throughout this chapter. And so here's one quick sample problem. Take 50.5 kilopascals and please convert it to millimeters of mercury, torr, Psi, and ATMs. And many times instead of saying the units, I give them kind of nicknames. This one, Kpa, is known as Kpas, Kpas. This one's known as mummy hugs, millimeters of mercury. This one's torr. This one's Psis right here. And then this is atoms right here, ATMs, atmospheres. So let's do the first one. Kpas to mummy hugs right here. So in Kpas, there are 101.3 in 760 millimeters of mercury. So you see my conversion factor comes right from here in this relationship, and then I would take these two numbers, 50 times 760 divided by 101.3, and I'd end up with 300 and something or so, so 760, I end up with about 380 or so mummy hugs. My next example problem is Kpas going to Psis. And my relationship comes from right here. There's 14.7 Psis in 101.3 Kpas. Maybe you caught on that 50.5 is about half of 101.3. So in effect, we're just taking 14.7 and we're just about dividing it by 2. So I end up with about 7.35 Psis equaling 50 Kpas or kilopascals. And the last one, 50.5 Kpas to atmospheres. My relationship is that there's 1 atmosphere for every 760, I'm sorry, not 760, my bad. Kpa is 101.3, 101.3. So 50.5 times 1 divided by 101.3 is approximately 0.5 ATMs, not worrying too much about sig figs. You need to be good at converting between these, and so having these units right here handy so then you can look and convert back and forth becomes very valuable to you during this unit on gases.